Hello everybody. Today I'll be finding the projection a onto b, and then we'll be taking the orthogonal complement of that projection, a orthogonal to b. I'm going to run through it pretty quick because it's actually not that hard. It's quite simple. I'll just show you. First, let me show you the equation. My handwriting's awful, so bear with me. But if we want to project, b, oh no, oh geez, b onto a is equal to the dot of b and a divided by unit vector of b squared multiplied by vector b. And this, what's going on here, is going to be a scalar multiplication. And after you compute this will get you a scalar, and you will multiply this to the actual in vector form vector b. And don't worry, I'll show you everything. Just so tired, so I'm stuttering a lot, so forgive me, but such is life. Now let's get into it. So we'll be taking the dot. We have our values here. So if you wonder where I'm getting these values from here, I assume you know how to take a dot product, but in case you don't, I'll tell you. You'll be multiplying the corresponding dimensional values. So the x value of vector A times the x value of vector B. Y value of vector A times the y value of vector B. Z for A multiplied by Z for B, etc. for however many dimensions you have, and you add them all up. So let me do this now. -2 times -5 plus 8 times -10. That's our numerator. You know, it sucks because I deleted the equation, but you can jump back to look at it. We'll just be following that equation the entire time. That's all we got to do. And for this, we'll show you. For the orthogonal complement, I'll show you. Okay, so then all we have to do is -3 squared is 9, plus -5 squared is 25, plus 8 squared is 64. Because remember, our denominator is going to be this, squared. So we take all this. I'm going to put it into a calculator real quick. -7 times -3. I have to say it out loud because I did a video on the same thing like 10 seconds ago. I got all the way to the end, and I put a 1 instead of a 2 in the calculator. It wasn't on purpose. It was a fat finger. And I got it wrong. It was very embarrassing to myself. But I could blame it on the lack of sleep that I got. Okay, so that's interesting. This is just equal to -1/2. Now I'm going to delete all this and start anew. There's more to the equation. If you still remember, we still have to multiply it. This is our scalar value. Multiply it by b. Very, very, very simple. You just literally just boom, boom, boom. So 1.5, 2.5 for -4 because it's -1/2. Okay. Oop. Shit. Excuse my language. Move that to my other monitor real quick. 2.5, wonderful. Orthogonal components, very easy. We're just taking these and we're subtracting the corresponding dimension to the corresponding dimension in A. Since we're projecting A onto B, we will be subtracting this from A. So simply, this is where I messed up last time. Instead of, it was like 2.333, and I accidentally said 1.333 into the calculator, and it just completely ruined my day. Not really. All right. -7 minus 1.5. This is also going to be in vector form, by the way. -8.5. -2, oops. See, I almost messed up again. -2 minus 2.5. -4.5. -10 minus -4. -6. So that is how it's done, ladies and gentlemen. I hope you learned something if you watch this video. Otherwise, I hope that this was mildly entertaining. Regardless, I'll probably be posting more math videos in the future because this is a lot of fun. It's also pretty much I don't actually expect anybody to watch any of these, but the main reason why I do this is because you get to remember everything you learn when you like go over it out loud. So it's a good way for me to learn and remember. Anyways, I'll see you.